Hello everyone, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is path with minimum efforts. Let's read the question first. Our question said, you are a hiker preparing for an upcoming hike. You are given a height of 2D array which is row into columns where height of row column represent the height of cell. You are situated in a top left cell means at 0 0 index, and you hope to travel to the bottom right cell means at the last index which is row -1 and column -1. You can move up, down, left, right, and you wish to find a route that required the minimum efforts. So here, what's the definition of minimum efforts? A route efforts is the maximum absolute difference in height between two consecutive cells of the route, right? So here in the first example, we are given a row equal to 3 and column equal to 3, and 3 into 3 we are given a matrix in terms of height array, right? So here the output is 2. Okay, so let's understand this question better. So if you see here, this is the array we are given, or we can say that 2D array, right? So what we have to calculate here, if you see, this is my source where I am right now. Okay, so I want to reach to my destination, which is this. Okay, okay. So in which path we can move? If you see, right now I am at 1, right? 1. Can I go to 2? Let's check this path. And 2, again we are going in this path, 2 to 2 and 2 to 2 and 2 to 5, right? Means this path, this path. Okay, 1, 2, 2, 2, 5, right? So if you see, what's the difference between this? 1, what's the difference? 0, what's the difference? 0, what's the difference? 3. So in this case, in this path, what's the maximum difference? 3. Let me write here. Okay. Now let's check for another case. Okay. So this is the first path. Let's check second path. I have start from the source, which is 1, go to 3, go to 5, go to 3, go to 5. This is another path, which is this path. Okay, and we can also choose this path, right? Source to destination, which is 1 to 3, 3 to 8, 8 to 3, 3 to 5. So what's the difference here? 2. What's the difference? 5. What's the difference? 5. What's the difference? 2. What's the maximum? Which is 5. Let me write here. So let's check this path also. Max difference 2, difference 2, difference 2, difference 2. What's the maximum? It's 2, right? So right now we have to take the minimum out of that maximum values. What is that? That is 2. That is my output as you see in the case, right? So the root effort is the maximum absolute difference in height between any two consecutive cells of the root. So if you see here, I am taking the difference between absolute consecutive elements, right? And after that I am taking the maximum out of it, and when we have the maximum we have to take the minimum out of the maximum. That will be my answer. So we have to travel from source to destination, and in which path have the minimum absolute difference we have to return, right? Hope you understand first the problem. Let me erase this first. Okay, now let's see how we can solve this question. If you see in the question, we are given some points, right? So let's assume some of the points which we are given. First is shortest path, right? We are given source to destination, minimum. Which algo is helpful to solve this question? Think about it. So the wait is over. So Dijkstra algorithm is helping to solve this question, right? So we are just doing the same concept what we are doing in the Dijkstra algorithm, right? So let's do step by step. In Dijkstra algorithm, what we are doing is using, if we are using priority queue method, right? In this case, what we are doing, we are just storing two values, node and distance, right? And also we are creating a vector, distance vector, right? But here we have 2D array, so we have to take the 2D array. So let's create a 2D array where we are storing our answer, and out of that we extract what we want, right? So let's write this. This is dixt. It's a distance array, right? So here we have to take the priority queue. So as you know, in the Dijkstra algorithm, So first step is, this is my source to source. What's the distance? 0. So let me write here 0, right? Else, where I'm writing nothing, so just assume there is a infinite value, very much value, right? So here what I'm doing is, I'm creating a min heap of three values. First is difference, second is row and column, it's indexing, right? So this difference is 0, right? This to this is 0, and what's the row and column? It's 0 and 0, right? Okay, cool. After that, what we are doing right now, I'm here, okay? So I'm just extracting this value. So if you see here, what is my diff right now? It's 0. Where I am right now, 0 and 0, this is my index. So in the question, as you see, we are given you can go up, down, left and right. So let's do this. Can I go up? Just assume, can I go up? Nothing. In this case, nothing is there, right? So I cannot go up, right? Can I go left side? No, I cannot. Can I go right side? Yes. Here we have 0 comma 1. I can. So if you see here, what's the difference between these two values? 1 and 2. What's the difference? It's 1. So let me write here diff. So let's create d here, because diff we are already using. D equal to 1, right? What's the maximum out of these? 1, because I want the maximum. Right? So what's the maximum? 1, right? Let me write here 1. And when I am writing 1, I have to push that into my DQ, which is difference is 1, in which case you are written that 0 comma 1. So let me write here 0 comma 1. Okay, cool. So can I go down? Yes, you can. So that's the index is 1 comma 0, right? If you see here, what's the difference between these two? It's 2. It's 2. Can I write here? Yes, because right now it's empty, but just assume it's infinite, because I have to write the maximum value. So can I write here? Yes, you can. I'm writing here 2. Okay. After that, what I'm doing is, again I have to push that value difference, which is 2, right? Here the difference is 2, and what's the indexing of it? It's 1 comma 0. Okay. Okay. Now after that, we are using min heap, right? We are using min heap. If we are using min heap, what will be at the top of min heap? 1, this value. So let's delete this. Now our top value is 1, or this value difference is 1, and we are at this index 0 comma 1. If you are at here, just think about, if you are here, can I go up? No, I cannot. Can I go left side? Yes, you can. Yes, you can. What's the difference between these two? 1, right? And here already we have the minimum, right? Already we have the minimum, because my diff is 1, and in this case, what's the d is? Because d is 2 minus 1, which is 1. What's the maximum? 1. So here we have to write the minimum, right? Here we have to write the minimum, which is 0. So we cannot don't need to update it. Okay. So can I go right side if I am here? Yes, you can, with the index of 0 comma 2, right? So what's the difference here? D is 2 minus 2, which is 0. What's the maximum? It's 1. What is here? It's infinite. Can I update? Yes, you can. Let me update this. And at the same time, we have to push that value into my PQ, which is 1. And what's the indexing is? 0 comma 2. Okay. Can I go down? Yes, you can. So what's the indexing is? 1 comma 1, right? What's the difference between these things? Let me write D. So 2 minus 8. Absolute difference is 6. Okay. What's the maximum here? 6. Can I write here? Yes, because here we have infinite right now. Let me update 6. Same time, what you are doing is, you have to write here 6, and what's the indexing? 1 comma 1, right? So this is also finished, because we are going in all the four directions. Okay. So let me erase this. And right now, if you see, what is my diff right now? So it depends upon what's the minimum, because we are using min heap. What will be at the top? This will be at the top. Diff is 1, and we are at 0 comma 2 value, means at this value. Okay. So let me erase this, because we are not. So can I go up? No, I cannot. Can I go right side? I cannot. Can I go back to left side? Yes, you can. What's the indexing here? Indexing is 0 comma 1, right? So what's the difference between these two values? 2 minus 2, which is 0. What's the maximum? D equal to 0 here. What's the maximum? 1. Okay. So 1 is already there. No need to update, right? So can I go down? Yes, you can. If you are right here, what's the index when I go down, which is 1 comma 2, right? So what's the difference is? It's 0. 2 minus 2, which is 0, right? What's the maximum here? 1. So let me write here 1. You can also visualize this thing. 1 minus 2. This path I am written now. 1, 2, 2, 2, 2, 5, right? What's the difference here? 1. Here I am writing. What's the difference? 0. But I have to write the maximum out of it, right? Here we have 0. Here we have 3, right? In this case, we have to update this also. Okay. So this part is also finished. Okay. After that, we have to choose. Okay. If you see here, we are updating this, right? When we are updating this, we have to also add this value into it. Let me write add first. This is 1 and index is 1 comma 2, right? Okay, now we can delete and extract what is at the top. So if you see, top is this 1 comma 2, right? Can I go when I am here? Can I go right side? No, I cannot. Can I go up? Yes, you can, right? Which is 0 comma 2. What's the difference? It's 0, right? It's a 0. D is 0. And what's the maximum out of these two? Which is 1, and 1 is already there. No need to update. Okay. So can I go to the left side of it? Means 1 comma 1 index. Yes, you can. What's the difference here is? It's 6. Okay. What's the maximum? It's 6. 6 is already there. No need to write. Okay. Can I go down? Yes, you can. Yes, you can. What's the indexing here? Index is 2 comma 2, right? So what's the difference? 2 minus 5, which is 3. So let me write here 3. So can I write here? Yes, you can, because it's infinite right now. So let me update this 3. And at the same time, I am pushing that 3 into it and with the 2 comma 2. Okay. You are reached to the destination, but mark my words, it's not your answer, right? If you see here, this is a path where I am updating the values, but it's not your correct value, right? So let me go forward, right? After this is finished, when this is finished, so what's my top value of mini heap right now? If you see, uh this value is the top because 2 is the minimum value. Let me delete this. Diff is 2 and add 1 comma 0, right? 1 comma 0 means this place, right? Can I go up? Yes, you can. What's the indexing here? 0 comma 0. What's the difference between these two is? D is 2. So D is already there, 0. I want the minimum in this case, right? So no need to update. Okay. Can I go left side? No, I cannot. Can I go right side? Oh, let me write D equal to 2 here so that we cannot confuse. Okay. So can I go to the right side when I am here? Yes, you can. Yes, you can. What's the indexing over it there? 1 comma 1. And if you see the difference between these two things is 3 minus 8, which is 5. So let me update D for this case is 5. So just check what's the value here? 6, which is bigger than this 5. So let me update here 5, right? So right now we are updating 5, and when we are updating 5, we have to push that into this, which is 1 comma 1. Okay. Can I go down when I'm here? Yes, you can. Index is 2 comma 0. So what's the difference here is? So the difference here is 2, right? If you see, the difference is 2, right? Here is we are writing nothing. So let me update this 2 here, and at the same time in my PQ I am updating the value, which is 2, right, at 0 comma 2. Okay, cool. So this is also finished. Let me erase this also. Now again you have to select from the minimum value. What's the minimum out of it? This value is the minimum, right? So what's the difference? 2. Right now we are at 2 comma 0, right? 2 comma 0 means we are at here 2 comma 0, right? When we are at here 2 comma 0, okay, so can I go up? Yes, you can, but the difference is 2. 2 is already there, so no need to go, right? Can I go left side? Nothing. No, I cannot. Can I go down? No, I cannot. Can I go to the right side? Yes, you can. Yes, you can. What's the right side value? 2 comma 1, right? What's the difference? 2. D is 2. What's the maximum out of these? 2. So let me update here 2, right? So when I update 2 here, we have to add 2, and what's the index here? 2 comma 1, right? So this is also finished. Again, you have to choose what is the minimum value in the min heap, right? So this is the minimum, diff is 2, right? And your index is 2 comma 1. Right now you are here. Can you go left side? Yes, you can. What's the difference? 3 minus 5, which is 2. 2 is already there, so no need to update. Can you go down? No, I cannot. Can you go up? So what's the value in the up, which is 8, right? So 3 minus 8, which is 5. You cannot update because 5 is already there. No need to update. Can you go to the right side? Yes, you can. What's the index? 2 comma 2. What's the value? 5. So 5 minus 2, sorry, 5 minus 3, which is 2. So what is your D here? D is 2. This is 2, this is 2. What's the maximum? It's 2. What is here? 3, which is bigger value, right? So let me update this with 2, right? So when I update this 2, I have to write difference, which is 2, and the indexing part, right, which is row and column, which is 2 comma 2, right? Now if you see clearly here, now if you extract what's the minimum, just is the minimum, difference is 2, and you are reached to your destination, right? You are reached to your destination. See this, you need this now. You have to reach here. What is your destination? 2 comma 2, that is your destination, right? After that, no need to solve, no need to go forward in the PQ, which is bind min heap, right? No need to go, because any value after this is bigger, right? Because if you see here, 5 is there, 3 is there, 6 is there, all the values which is after my this case, when I reach to destination, it should be greater or equal or greater, right? So what I'm doing is, this is your answer, your diff is your answer, this is your output, right? I hope you understand this, right? That's why we are using the min heap, so that we can need the minimum value, because the minimum value we need is diff, which help us to solve this, right? So let's code this now. So as I said, we are using the min heap. So let me write here priority queue first. Okay, so we need the min heap. So we are using here three values. One is for the difference part, okay, and one second and third will be for the row and column index. Now let me create this for vector part, 1 2 3. Yeah, good. Now we have to write the greater, which is also for the same pair of int 1 2 3 4, and this is the name of it, PQ, right? And right now we have to create a 2D vector. Let me name it as dist, right? And its size is rows, and we are initialize its value as maximum, columns 1e9. Yeah, it's correct. Okay, so initially what we are doing in the dist part, at 0 comma 0 we are writing 0, right? And we have to push the value, which is difference is 0, because we are at the initial source part, right? 0, and its index is also 0 comma 0. Yeah, it's correct. Okay, so this is the condition of while. When it should be empty, we have to stop, right? Okay, after that we have to extract the top element of it. Let me name at it top. At the same time we are popping this, right? After popping this, let me extract the value from it, which is it dot first is my difference, right? And the row is it dot second dot first, okay? And the column is it dot second dot second, right? Okay, now we have the column, we have the rows value, right? We have the diff. Now it's time to move in the four directions. So we have to go in the four directions. If I go up, row minus 1 and column, and if I go row plus 1, column is there, right? And if I go into the left side, okay, so that will be column minus 1, but row is same, column minus 1, okay. And in the right side, my row is same, but column plus 1, right? So let me create here a vector for that, direction of rows, which is of 4 size, right? And it should be like minus 1, 1, 0 and 0, right? And direction of columns, which is also a size of 4, and it should be like 0 and 0, minus 1 and 1, right? Okay, so yeah, after that what I'm doing is I'm moving in the 4 direction, so I'm running the loop in the 4 direction. Okay, in the 4 direction what I'm doing is, let me create here first new row, right, which is row plus, which is r, plus direction of rows of I, right? And if I to calculate the new column, which is column plus direction of columns of I, right? Now it's time to check it's in the bound or not. It should not be out of bound. So let me check if new row is greater than equal to 0 and new row should less than rows, right? And same for the column. So new column, this should greater than equal to 0 and new column should less than columns, right? If it's in the this conditions, now it's time to check the new efforts. Let me create a variable new efforts where we have to check what's the maximum diff or d, right? Remember diff or d. So here I am writing max of abs of, right? We have to take the absolute difference between heights of initial where we are standing and where we are going, means the new heights, which is new rows, it's row, right? It's new row and new column, right? So we are taking the difference and we have to compare with the def already we have, right? If in the vector part, in the dist vector 2D matrix, if my desktop, new row and new column, if this is greater, if it's the greater than my new effort, so in that case what I'm doing is I'm updating the value there. So my desktop, new row and this column is new efforts, right? Okay, at the same time what I'm doing is I'm pushing that into my min heap, right? So that is new efforts, okay, and that new column values, new row and new column. Okay, so this is all, right? And here we have to write if my row equal to, like it, when my row and column reach to the destination, so what's the condition? When row equal to row minus 1 and column equal to columns minus 1, right? Let's check columns, yeah. So we have to return the diff, that is the minimum, right? Minimum value. At the end of it what I'm doing is let return 0, right? So this is whole. Let's check it's working fine or not. If any error we can solve. Yeah, the okay, so new efforts, let's change, it's not new effort. Okay, it's new effort. Okay, now let's compile and check. Here also we have to update its new effort. Yeah, its compilation is good. Let's submit and check. As you see, all the cases are passed, right? So let's talk about time complexity. So in the grid, in the 2D matrix, like we have n cross m, for example, n cross m is the size of it, right? And we are traversing each value one time. And inside this, we are doing the min heap. So in the min heap, we are going into the forward direction. So the loop is 4 into log of m into n, because we are using the min heap here, right? So this is the simple time complexity of it, right? So I hope you understand the solution and intuition. Thank you so much.